myself that. Okay, let's go to this sheet. Okay, here's our coins. I'm going to take our 3 coins and we're going to look at every possibility. Okay, and when I look at every possibility, every outcome that we can have, well, all those they're all if they are all um, uh, um, if all these outcomes added together equals 1, right? Then I should be able to predict what the probability of each of these outcomes is going to be. I'm going to just hit escape there so I can get away from that. Okay, let's take a look at this. Probability of heads, heads, heads. Let's say all the different possibilities that could occur. I could get a possibility of I could get a head, and a head. I could get a head, and a tail. I could get a head, a tail, and a head, a tail, and a tail, and so on and so forth. You have all these possibilities. Now, let's see, there's 2 possibilities for the first coin, right? There's 2 possibilities for the second coin. So 2 times 2, we're up to 4 possibilities. And for the third coin, we now are double that and we're up to 8 possible outcomes. And all of these possible outcomes are equally likely because all of these are independent events and each one is 0.5 times 0.5 times 0.5. So let's see what happens here. Okay, now let's see, each one of these events has the same probability of occurring, right? Each one of these events, tail, tail, head, head, tail, tail, and so on and so forth. Okay, let's take a look at this. Okay, the probability of, let's say we're looking at the probability of getting heads alone. 3 heads, 2 heads. This would be 2 heads, head, head, tail. This would be 2 heads, head, tail, head, and so on and so forth. Let's calculate the probabilities. Probability of getting all 3 heads would be 0.5 times 0.5 times 0.5 for 1.25. The probability of getting a head, and a tail is going to be 0.125. The probability of getting, and that would be 2 heads. So here we got 3 heads here, we got 2 heads here, and so on and so forth. I've already outlined them here. Okay, and I'm going to copy them down here. If you go through each one of these possibilities, this is the number of heads that it represents, right? This is a head, this is a tail, this is a tail. Okay, on this end, we're starting with first coin is a tail, then a head and a head, so that's 2 heads here. Okay, this is going to be a head, a tail, a head, and a tail, so that's 1 head there, and so on and so forth. 1 head here, and of course here, this is tail, tail, tail. That's going to be 3 tails, or in other words, another way of saying 3 tails, say 0 heads. Okay, so now let's take a look at these possibilities now. Remember before we asked ourselves, what was the question we asked ourselves? The probability of 2 out of 3 outcomes are heads. What's the probability of 2 out of 3 are heads? Okay, let's go back here. How many times did we get 2 heads? Once, twice. Okay, 0.125, 0.125, 0.125. There are 3 ways that we got each one of the likelihood of 12.5%, right? There are 3 ways that we were able to get exactly 2 heads. So the probability of getting exactly 2 heads is going to be 0.375. What's the probability of getting 1 head? Probability of getting exactly 1 head is 1, 2, 3 is the same thing, 0.375. Well, if you think about it, probability that's getting 1 head is the same thing as getting 2 tails. And since the coin is 2-sided, we would expect that to be 0.375. What's the probability of getting no heads? Well, we know that even from the beginning, 0.5 times 0.5 is 0.125, or 3 tails, and so on and so forth. It's going to be the same thing. This tree, this probability tree, will help us work some of this out. In the long term, we're going to find more economical ways of doing this rather than spending time on this. I'm going to alter things a little bit. It works out very neatly when you only have you have a coin flip, which is 50-50, right? So now let's take a look at it from another perspective. Let me just take a quick look over here. Question. The wording is very important, right? As you're going to find in statistics quite a bit. Okay, what if I had asked you, what's the probability of getting 2 or more heads? Okay, in 3 coin flips. Well, 2 or more heads would say 3 satisfies that. 2 satisfies that, 2 satisfies that, 2 satisfies that. So there's 4 ways to do that. 4 out of 8 is 50%. 50% chance of getting 2 or more heads. What's the probability of getting 1 or less head? 1, 2, 3, and 0, also 50%. Right? So yeah, that's important. Okay, so now let's take a look at the next part. Okay, now this time I'm going to change the probabilities a little bit. We have a test that asks 3 questions. Questions are unrelated, and getting the first question right doesn't influence the likelihood that you get the second question right or the third question right. They're all independent events. Let's say the probability of 50% of the students got question 1 right, 80% of the students got question 2 right, and 50% of the students got question 3 right. Okay, most tests you would think that a student that's smart and gets the first question right, he's got a better chance of getting the second question right too, right? Well, in this particular case, the way the questions are, they're completely independent, completely different subjects, and there's no likelihood that there's any association between question 1, the result on question 1, question 2, and question 3. Okay, let's take that as a given. Okay, just so we can do this problem. So let's say the probability of student get question 1 right is 50%. Let's say that the probability of get question 2 right is 80%. Let's say the probability in question 3 right is 50%. So now we have a number of different possible outcomes. A student can get all 3 right? And we know if he gets all 3 right, that's easy. That's 50% times 80% times 50%, right? That's an easy one. In fact, we have it right here. 0.5 times 0.8 times 0.05, that's going to be equal to this times, whoops, it hit it on me, times times what is that, I3, right, is 20% chance of that occurring. Okay, so now that's pretty obvious, right? 0.25 times 0.5 is a quarter times 8 is 0.2. Okay, so now what's the probability of someone getting the first question right, second question right, and the third question wrong? Oh, well, that's going to be 0.5 times 0.8 times 0.5 is going to be equal to, see what that comes out to. That's going to be equal to 0.2 also. Okay, 0.5 is times 0.8 is 0.4. 0.4 times 0.5 is 0.2. How about this? 0.05. How about what's the probability of getting the first question right, the second question wrong, and the third question right? That's going to be equal to this number times this number times this number is going to be 0.05, a little less likely. What's the probability? Why is that? Because most people got that question, that middle question right. 80% of the time they got that right. How about now? This is equal to 0.5 times, I'm just doing it backwards because it's not going to block out as it expands that formula. It's not going to block out that cell for me, so I can't get to it. Okay, and so on and so forth. I'm going to do it for each one. Okay, it's a mirror image actually, so I could have saved myself a little work. But I'll go ahead and step through it. Oops. Let me try that again. Okay, and this one. And so on. And finally, we know this one's going to be the same as the top one. Oh, not the same as the top one, because it would have been if it were coins, because 50%, but this is a lot less likely. Getting all 3 wrongs is a lot less likely than getting all 3 right, because question 2 was so easy. Okay, so now let's take a look at this. Let's see what they add up to. See what all these probabilities add up to. Okay, add up to 100%. These represent all the possible outcomes. So now let's see what we have here. If I asked you, what's the probability of getting 2 questions right, okay, in this exam? Well, I got 3 right here. We got 2 right here. We got 2 right here. We got, let's see, 1 right here. We got 2 right here. We got, let's see, 1 right here. We got 1 right here. And finally, we got none right here. Okay, so what's the probability of getting exactly 2 right? Well, it's going to be 0.2 plus 0.05 plus 0.2 or 0.45. 45% chance of getting, if we randomly pick a student, it's a 45% chance that he got 2 right. Doesn't matter which 2 he got right, but that he got 2 right. Okay, is everybody comfortable with that? I'll go through one more. What's the probability that he got less than 1 right? 0.5 plus 0.2, 0.25, plus 0.05, 0.3, plus 0.05 is 0.35. 35% chance that he got 1 or 0 right, or 1 less than 1 or less than 1. Okay, guys comfortable with that? Right? That's not that difficult. So I think when you get into the lecture, you may be seeing things that are a little bit more challenging, but I think this will be a good introduction to you. And I'll see how the lecture goes, and maybe I'll tinker with this a little bit for the second half. And depending on which one seems to have come out better, I'll post one or the other. Okay, so now let's move on to the next thing that we're talking about tonight. And that is diagnostic testing. Okay, let me